Alright, so today we're going to be going over synthetic division. So similar to long division, but just another method. A little easier, I think. So we have this k minus 3, we have this polynomial divided by k minus 3. If you think about k minus 3 for a second, if you set it equal to 0, you would get a solution of k is equal to 3. So I'm actually going to divide everything by 3. I'll put a little 3 here on the outside. And what I'm going to do is I'm going to write all the coefficients in front of my variables. So k to the fourth is really 1 k to the fourth. K to the third has a positive 2. K squared has negative 8. K has negative 22. You're going to negative 5. I'm going to draw a line. And I'm always going to bring down my first term in that manner. So k minus 3, there's a 3 on the outside. If this was k plus 3, then there'll be a negative 3 on the outside. Alright, just the opposite. Alright, so 3 times 1, I'm going to multiply. 3 times 1, I get 3. And then I add 2 plus 3, and I get 5. 3 times 5, 15. And I add negative 8 and 15, 7. 3 times 7, 21. Negative 22 and 21. Negative 1. And lastly, 3 times negative 1, negative 3. Negative 5 and negative 3 is negative 8. So k minus 3 would not be a factor, okay? But we have a remainder, so we start now with our 1 here. So we're going to go 1 degree less. So k to the fourth now becomes 1k to the third plus, because it's a positive 5, 5k squared plus 7k, you don't have to write to the first, but to the first, minus 1, and then my remainder, minus 8 over k minus 3. So looking at our second example, I have this polynomial divided by k minus 1. Again, if I take k minus 1, set it equal to 0, I get k is equal to 1. So I'm actually going to divide by the 1 here on the outside and write down all my leading coefficients, which are 1, 9, negative 18, 16, negative 9. Okay, and I'm always going to bring down my first term, which is 1. Alright, so I'm going to multiply 1 times 1, I get 1. 9 plus 1, 10. 1 times 10, 10. Negative 18 plus 10, negative 8. 1 times negative 8, negative 8. 16, negative 8, 8. 1 times 8, negative 9 and 8. Okay, so this tells me I have k to the third plus 10k squared minus 8k, right? Just going down and just bringing each degree down 1 unit, plus 8, and then remainder of minus 1 over k minus 1. Polynomial divided by a plus 4. I'm going to take this a plus 4 on the side, set it equal to 0, and I'll get a is equal to negative 4. So now I have negative 4 in my box here, and then I write down my leading coefficients, 7, 24, negative 15, negative 5, negative 45. I'm going to draw my line, and I'm always going to bring down my first coefficient. All right. Notice in the examples I'm giving you, all my terms are decreasing, right? A to the fourth, a to the third, squared, and so on. If one of these are missing, just like long division, you have to put a 0 in here as a placeholder. Right? So if this was just 7a to the fourth plus 24a cubed, and this term here was missing, and it just went to negative 5a, then you must put a 0 in here, right, as a placeholder. Okay, so let's get rid of that. Alright, so let's do this. Negative 4 times 7 is negative 28. 24 and negative 28, I get negative 4 and negative 4. Negative 15 and 16. Negative 4 and 1. Negative 9 and negative 4. I'm sorry, negative 5 and negative 4, negative 9, thank you. And negative 4 and negative 9. 36, and negative 45 and 36, negative 9. Okay, and then just rewrite these. 7a to the third minus 4a squared plus 1a, or just a, minus 9 minus 9 over a plus 4. This one, I actually just want to go over one topic from throughout the year. So if you have a fraction that looks like 1 over 2n plus 4, this is the same thing as writing 1 over 2 times the quantity of n plus 2. Do you agree? And this is also the same thing as saying 1 over 2 times 1 over n plus 2. Do you agree with that? Okay, so we're going to keep that in mind for a second, okay? And we're going to show you how that comes back into play on this problem, all right? So I'm going to erase that, just keep that in mind. All right, so here I have 3n minus 6, and what I suggested to you guys was when you're doing synthetic division, you want a leading coefficient of 1, right? So let's get this leading coefficient to be 1. So what do I do here? I could factor out a 3, and I'm left with n minus 2. All right? So again, I'm going to take the 2 here. So n minus 2 means I'm going to have a 2 on the outside. And I'm going to forget about this 3 for a second. Okay? So I have 2, and then I have 3, 12, negative 15, negative 21, and negative 47. Bring down my 3. Okay, so if I start this, I get 2 times 3, 6, 12 and 6, 18, 2 times 18, 36, negative 15 and 36, positive 21, 3 times 21, 2 times 20, oops, excuse me, 42, and I get positive 21, 2 times 21, 42 again, and I get negative 5. All right, so here then I'm left with 3n to the third plus 18n squared plus 21n plus 21 minus 5 over, and what did I divide by? N minus 2. Right, I kind of excluded that 3 from here for a second. So I'm taking this whole fraction, or this whole polynomial, and I'm dividing by 3 times n minus 2, correct? So just like what I showed you before, the 3 that I wrote here can actually be written here on the outside as 1 over 3 times all that. Yes? So if I kind of extend this line here, so what I have to do is, since I disregarded this 1/3, I'm going to go back and I'm going to multiply everything here by 1/3. So 1/3 times 3n cubed would just be n cubed plus 1/3 times 18, 6n squared, plus 7n plus 7 minus 5 over 3n minus 6, which brings me back to my original number I'm dividing by. And then this would be my final answer. So if you have a leading coefficient, there's an extra step you have to take in synthetic division. Factor it out, get a leading coefficient of 1, use that number, and then divide by that 1/3 at the very end. Right? Otherwise, you'll have a multiple of the answer, but not the exact answer.